Hello guys, today we're going to be looking at a mock IA for Pure Maths Unit 1, Module 1. Without further ado, we get right into the questions. So the first question says, let P and Q be two propositions. Complete the truth table below. Now, we already have the inputs for P and Q. And notice that we have four inputs because we have two statements. Right? Now, notice it's 2 to the n, where n is the number of propositions. Now let's start with not P. Not P means that it's negating whatever P is. P is true, true, false, false, which means that when I negate that, I'm going to have false, false, true, true. Not Q, we apply a similar concept. So we have to negate whatever we see. So we have true, false, which means we're going to have false, true, true. Now P or Q is a statement that is correct as long as one of these propositions are correct. So we're going to be looking at P and Q. All right, P is true, Q is true. So it means that P or Q is going to be true. When you combine true or false, still going to be true. False or true will definitely be true. And then false or false will have to be false. The negation of P or Q, which means we're going to be taking opposite of this column, which is going to be false, 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 true. Now, not P and not Q, right? And symbolically, we can write it like that. So we're looking at these two columns, and the outcome is only true if the two inputs are true. So let's look through it. This is going to be a false scenario. Well, not P and not Q, because both are false. This is false because one of them is false. This is also false because not Q is false. So the only outcome that is true is when both of them are true. So we can start with that, and we know that everything else is false. Now state what are the statements, negation, P or Q, and not P and not Q. And of course, again, symbolic representation is this, are logically equivalent. Now we look at these two columns, which is columns 6 and 7. Now, you can see that the outputs are the same. We have false, 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 true, false, 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 true. So we can say that the negation of P or Q is logically equivalent to not P and not Q because the output in columns 6 and 7 are the same. So columns 6 and 7 are the same. Right? So that would be it for the first part of the question. Now looking at part B, it says use mathematical induction to prove that 5 to the n minus 1 is divisible by 4. So the first thing we're going to have to do is to prove for n equal 1. So we're going to have prove for n equal 1. Alright, 5 to the 1 minus 1 is equal to 4a. Of course, where a is some integer. Now this boils down to give me 4, which can be expressed as 4 times 1. Alright, so we know it's true for n equal 1. Now we're going to have to assume true for n equal k. N equal to k. So we're assuming that 5 to the k minus 1 is equal to 4 times some integer. We could call it anything, m, n, whatever we want to call it. Let me call it 4m. Alright. Now, of course, since we assume this is what we'll have to use to prove for the next step. So we can go ahead and say 5 to the k is equal to 4m plus 1. Good. Once we have that, then the most important step is to prove for n equal k plus 1 that what we want to prove is that 5 to the k minus 1 is equal to 4 times, let me call it 4 times r. Alright, we want to prove that it's going to be 4 times something. Now, this should have been k plus 1, so this is 5 to the k plus 1 minus 1. Let me just take it as 5 to the k plus 1 minus 1. Now, of course, I'm going to have to go back to this step, the assumption step, for this statement right here, so I can substitute it into this. So I'm going to start by rewriting this. So this becomes 5 times 5 to the k minus 1. Alright, but we know that 5 to the k, so but 5 to the k 4m plus 1. Of course, this is from my assumption step. So this is going to become 5 times 4m plus 1 minus 1, which we can say 20m plus 5 minus 1. This can be written as 20m plus 4. Now, how do I show that this is really divisible by 4? I should be able to factor out a 4. So I'm going to have 4 bracket 5m plus 1. Alright? And you could even take it a step further and say let 5m plus 1 equal r. So this becomes 4r. Of course, which is definitely divisible by 4. Now, once you have done this, now you need a final statement which says proven true for n equal 1, n equal k, n equal k plus 1, and of course, and hence for all elements in my natural number system. Because that is what you really ultimately wanted to prove it for. Alright, we'll move to question C that says solve the logarithmic equation log 2x plus 2 base 4 plus log of x plus 1 base 2 is equal to 1. Now, the first thing I normally need to do is to look at the bases. Notice that we have base 4 here, we have base 2 here. That can't work. So we're going to have to get the same base. Now, we have different rules, but I'm going to use my change of base rule to change this from base 4 to base 2. So I'm going to have log of 2x plus 2 base 2 over log of 4 base 2 plus log of x plus 1 base 2 is equal to 1. Now that I have the same base, I can go right ahead and I can evaluate this. Alright, so this is going to be log of 2x plus 2. Now log 4 base 2 is simply going to be equal to 2, because all it's saying, what do I raise 2 to get 4? So this would be equal to 2 plus log of x plus 1 base 2 is equal to 1. Now, one of the things that we don't like to have, let me put in the base 2 here, is denominators when solving equations. So I'm going to multiply everything by my denominator. So I'm going to have log 2x plus 2 base 2 plus 2 log x plus 1 base 2 is equal to 2. Now, with this 2 here, I can bring it up as a power so we can simplify this. So I can say log 2x plus 2 base 2 plus log of x plus 1 all squared base 2 is equal to 2. Now we can combine these two expressions here. So I'm going to have log, and since I'm adding, I'm going to multiply them, right? So I can have 2x plus 2 times x plus 1 is equal to 2. And of course we can use the change, so we change this to the exponential form. Alright, so we can say 2x plus 2 times x plus 1 is equal to, this would be equal to 2 to the 2, which is equal to 4. Now, there are different things we can do to make this simpler, because I could, for instance, factor out a 2, which would give me x plus 1 times x plus 1 equal 4. I will divide both sides by 2. So we have x plus 1 all squared is equal to 2. Now, we wouldn't need to expand the brackets here. We would simply just need to take the square root on both sides. Alright, so I'm going to have x plus 1 equal root 2 So x is equal to root 2 minus 1. And in fact, let me not even leave it at that. Let me consider this to be plus or minus root 2. Right? So I would have root 2 minus 1, and I could also have minus root 2 minus 1. Now, of course, this one is not applicable, because if I were to take this and put it here, I would end up with a negative, which I can't log. So this is not applicable. So therefore, x is equal to root 2 minus 1. All right, we'll move to question D. It says the growth of bacteria present in a river after time t hours is given by n is equal to 300 plus 5 to the t. Determine the number of bacteria present at t equals 0. And next way they could ask this question is the initial number of bacteria present. That is always when time is equal to 0. So I'm going to have n is equal to 300 plus 5 to the 0. We know that anything raised to 0 is equal to 1 apart from 0 itself. So n would be equal to 300 plus 1, which is equal to 301. So initially, 301 bacteria would be present. Now the time required to triple the number of bacteria. All right, so let's say we triple this. It will be 3 times 301, which is 903. So I'm going to have to say n would be 903. So I'm going to have 903 is equal to 300 plus 5 to the t, because that is what we want. We want to find out what t is. So we simply transpose this. We're going to bring over the 300 first. So 903 minus 300 is equal to 5 to the t. All right, good. This is going to give me 603 is equal to 5 to the t. Now I want time. I could apply ln or I could apply log. It doesn't matter. So let me say we go ahead and we apply ln. So ln 603 is equal to ln of 5 to the t, right? So ln 603. We don't work this out yet because we want the most accurate answer. By laws of logs and ln, when you ln something with a power, the power comes to the front. So this is equal to t ln 5. So we divide both sides by ln 5. So therefore, t is equal to, and of course you can put this in your calculator now. So this is 3.978. And of course, with a time like this, we could have probably round it off to approximately 4 hours. All right. All right, next question says, let A equal a set of x such that x is a real number and x is greater than or equal to 1. The function f is such that A maps onto R, which is a real number system, is defined as f of x equal x squared minus x. Show that f is 1 to 1. All right. Since that this is a quadratic function, there are several ways that we could go about doing this. And one way is that we could actually sketch the function to show it. So what the first thing I could do is to complete the square, which is to express f of x in the form a into x plus h all squared plus k. All right, and as you know, h is equal to b over 2a and k is equal to c minus a squared. So h would be equal to negative 1 over 2, because you can see a is 1, b is equal to negative 1, and c is equal to 0. So k would be equal to 0 minus 1 times negative a half squared. K would be equal to negative quarter, as you can see. So therefore, f of x would be equal to a, which is 1, into x plus h. So I'm going to have x minus a half all squared plus k. But k is negative a quarter. All right. Now, what do I need from this? I need a turning point, which is actually negative h with k. So the turning point would be a half with negative a quarter. All right. We know that this thing will cut the y-axis at 0. So we can go right ahead and sketch it. So I'm going to have my curve. Please remember to put your axis, label your axis, y and x. And then of course, looking at the values here are pretty small, so I would want to space it. So probably I could even have 1 here, 2 there, -1, -2, 1, 2, -1, -2. So I need to find the turning point, which is a half, which is here, with -1/4, somewhere down here. All right, good. Now it's gonna cut the y-axis at 0. So it's gonna cut right through here, right through the origin. Now, what about where it cuts the x-axis? If we let the curve x squared minus x equals 0, all right, factor out an x, we can see that x would be 1 or x is 0. So it's also going to cut here. So we can go right ahead and sketch a quadratic function. It's going to look something like this. That is what it would initially look like. Now, let us look at the restriction that was given. It says that the domain is such that x is greater than or equal to 1. So initially, this function wouldn't be 1 to 1 because if I were to draw a horizontal line, this would fail the horizontal line test, which means it would not be 1 to 1 or injective. But because of my restriction that says x must be greater than or equal to 1, it now means that I'm going to have to find 1 on my x-axis, and I'm going to have to look at the function to the right because it must be greater. So I'm going to have to take off all of the function over here. Sorry? So this becomes negligible. Now, when I draw my horizontal, so let me label my function f of x. So now I'm going to have to draw my horizontal line. When I draw my horizontal line, like that, notice that it will only cut the function once. And that is what it takes to show that the function is 1 to 1 or injective. So we can say since, let me get this here, since f of x passes the horizontal line test, f of x is 1 to 1. Alright? Alright, next question says let f of x is equal to 2x cubed minus x squared plus px plus q, given that x plus 3 is a factor of f of x, and that there is a remainder of 10 when f of x is divided by x plus 1, show that p is equal to -25 and q is equal to -12. So let's start with the factor, x plus 3. So we're going to have to start by saying let x plus 3 equals 0, which would imply that x is equal to -3. This means that f of -3 is equal to 0, seeing that x plus 3 is a factor. So I'm going to have 2 -3 cubed minus 3 squared plus p times, well, this should be -3, so it's -3 squared. P times -3 plus q is equal to 0. Now, of course, we're not going to leave it like this. We're going to have to tidy this up. All right, so I'm going to have -3 cubed, that's -27, times 2, that's -54, minus 9 minus 3p plus q equals 0. So we can say minus 3p plus q equal minus 54 minus 9 is -63, and we'll bring that over. It's going to be positive 63, equation 1. All right, for equation 2, we can still use a concept that we get a remainder of 10 when it is divided by x plus 1. So let x plus 1 equals 0. It means that x would be equal to -1. So f of -1 would be equal to my remainder, which is 10. So we have 2 times -1 cubed minus -1 squared plus p times -1 plus q is equal to 10. We'll simply just tidy this up. This is going to give me -2 -1 minus p plus q equal to 10. So minus p plus q, -2 -1, that's -3, comes over as plus 3, so it's gonna have 30. This is equation 2. All right. Once we have that, we're halfway good to go. So we can probably just line up the two equations. Minus 3p plus q equal to 63. And then minus p plus q equal to 13. Alright? And we can subtract here. So minus 3p minus minus p will give me minus 2p. Of course, q is cancelled out, and 63 minus 13 is 50. Now we divide by minus 2. We have p is equal to negative 25. Alright, using the simplest equation, minus p plus q equal 13. We're going to have minus 25 plus q equal to 13. So 25 plus q is equal to 13. So q must be equal to 13 minus 25. Q is equal to negative 12. Alright, and we got exactly what they wanted. So you can write a statement and then QED, because it was a proof question. So we have exactly what we want. Alright, let's move to the next part of this question. It says, hence solve f of x equal to 0. Now let me start by writing back what f of x was. Is equal to 2x cubed minus x squared plus px plus q. Now of course we found p to be negative 25, and we found q to be equal to minus 12. So f of x is really 2x cubed minus x squared plus, well, since it's negative, I don't need to put plus there, so I can just say minus 25x plus 12. Now, in order to solve this, I'm going to have to factorize it. And since we have a factor already, which was x plus 3 is a factor, we can go ahead and do long division. Alright, minus 25x. This should be minus 12. Let me change this here. Just 12, q was negative, so this is minus 12. Minus 12. Now, x into 2x cubed is going to give me 2x squared. And of course, you know, you multiply 2x squared by that. That's 2x cubed plus 6x squared. And we subtract again. Now, minus x squared minus 6x squared is minus 7x squared minus 25x. Now, x into this is going to give me a minus 7x. Of course, minus 7x times that, minus 7x squared minus 21x. And of course, we subtract again. Now, this is 0. But negative 25x minus negative 21x is going to give me a negative 4x. And we carry down the minus 12. Now, x into minus 4x is minus 4. So I'm going to have minus 4x minus 12. When you subtract here, we end up with 0. Alright, so we're almost there. Now we need to, so we really have x plus 3 times 2x squared minus 7x minus 4. What we need to do now is to factorize the quadratic. So let me go AC on that. That's minus 8. Now we need to get minus 7, so it's minus 8 and 1. So you have 2x squared plus x minus 8x minus 4. Alright? Can take out an x, we have 2x plus 1. Can take out a minus 4, we have 2x plus 1. So we have x minus 4, 2x plus 1, and of course x plus 3. Alright, f of x is equal to this. Now of course, if several things multiply to give you 0, one of them must be 0. So if f of x is equal to 0, then x plus 3 is 0, x minus 4 is 0, and 2x plus 1 is 0, which would imply that x is either negative 3, 4, or negative a half. Right? You don't have to manually show you transposition for these. Alright, we'll move into the last question that says, given that alpha, beta, and gamma are roots of the equation 2x cubed minus x squared plus 1 equals 0, determine the equation whose roots are 1 over alpha squared, 1 over beta squared, 1 over gamma squared. Now, before I even get into the whole thing, note that I gave you some information that can be useful. The first thing I want to do is to start by writing down the important information that I will need, which is alpha plus beta plus gamma, which is equal to, let me change the color here, negative b over a alpha beta plus alpha gamma plus beta gamma, which is equal to C over A, and alpha beta gamma, which is equal to minus D over A. Alright, so we have sum of roots, sum of product of roots pairwise, and product of roots. Alright, now what is A, B, and C? Let me write it down from the equation. A is 2, B is equal to -1, C is equal to 0, and D is equal to 1. So this would be equal to, alright, and notice that B is -1 already, so you're just going to have 1 over 2. This is going to give me C. There's no x term, so C is 0. So this just is 0 right here. And then this is minus D over A, so this is equal to -1/2. Now, let me get into the equation. Now, since we're given the roots of the equation, you know the equation will take the form x cubed minus sum of roots times x squared plus sum of product pairwise times x minus the product equals 0. That's the general form that the equation will take. So what I'm going to end up with here is x cubed minus 1 over alpha squared plus 1 over beta squared plus 1 over gamma squared. That's the sum of the roots. Now the sum of the product pairwise, it just means that we take them 2 by 2, we'll multiply them. So we're going to have 1 over alpha squared beta squared plus 1 over alpha squared gamma squared plus 1 over beta squared gamma squared times x minus the product, which is 1 over alpha squared beta squared gamma squared equal to 0. Now notice that you were given some very important pieces of information up here. This is what you're going to be using to work this out. Alright, so you have all the information you need right here. Okay, so let's get right into it. Okay, here, let me just put the lines here and just work them out. I can find the LCM here because these are fractions, so we'll go ahead and find the LCM. Alpha squared, beta squared, gamma squared. Now alpha squared into this is going to be beta squared, gamma squared times 1. So I have beta squared, gamma squared. Beta squared into all of this will be alpha squared, gamma squared. And gamma squared into all of this will be alpha squared, beta squared. Which if I want, I could write it. And because addition is commutative, I could write it as alpha beta all squared plus probably alpha gamma all squared plus beta gamma all squared. I want it to write the same way so that we can use the identity that we actually have up here. Alright, which says all of this, and this is what we're using now. This identity here. This is equal to alpha beta plus alpha gamma plus beta gamma all squared minus all of that, right? So we can just write the equation here. We just go to the next line. So this becomes the same thing as alpha beta plus alpha gamma plus beta gamma all squared minus 2 alpha beta gamma alpha plus beta plus gamma. And of course you can populate it because we did work this out already. Let's go back up. The sum of the roots is a half, the sum of the product pairwise is 0, and the product is -1/2. So this is really 0 squared minus 2 times -1/2 times 1/2. Alright? This is going to boil down. So let's see what happens here. This is actually going to give me a +1/2. So I've taken care of that part. Now moving to the sum of the product pairwise. We also find the LCM here as these are fractions. So we have alpha squared, beta squared, gamma squared. Now this into this is going to be gamma squared. All of this into this is going to be beta squared. And of course this into this is going to be alpha squared. Using the commutative property again, we're going to end up with alpha squared plus beta squared plus gamma squared all over alpha, beta, gamma, all squared, because we can write it like that. Then we can go for the identity. So this is alpha plus beta plus gamma, all squared, minus 2 alpha beta, alpha gamma plus beta gamma, all over alpha beta gamma, all squared. We know these pieces of information already, so all we have to do is populate the thing. So you're going to have a half squared minus 2 times 0 all over negative a half squared. Okay, I think I probably left out the denominator here. Yeah, so this should be over alpha squared, beta squared, gamma squared. So this would have been alpha, beta, gamma, all squared, right? So all this would actually go over negative a half squared. So I would have a half over a quarter, which breaks down to give me 2. And likewise, we can put all this inside the calculator, right? We have a half squared. This will boil down to give us 1. And then finally, 1 over alpha, beta, gamma, all squared. This would be 1 over negative a half squared, which is going to give me 4. So now I have everything I need to put the question together. So I'm going to have x cubed minus the sum of the roots, which turned out to be positive 2, so 2x squared, plus the sum of the product pairwise, which turns out to be 1, so I'm going to have plus x, minus the product of the roots, so minus 4 is equal to 0. And that would be my equation that has roots 1 over alpha squared, 1 over beta squared, and 1 over gamma squared.